Okay, so as a reminder, what we talked about on page 3, and you're probably going to have to flip back and forth to page 3 to look at the relationships that we discussed yesterday. Alternate interior angles are congruent, corresponding angles are congruent, and alternate exterior angles are congruent. The consecutive angles, consecutive interior, consecutive exterior, are supplementary. So I'm just going to jot that down off to the side over here before we look at problem number 4, because we're going to need to use that for problems 4 and 5. So my congruent angles are alternate interior, alternate exterior, and corresponding. My supplementary angles are the consecutive interior and consecutive exterior. In addition to linear pairs and vertical angles that we learned about before. So those can also come into play, but these are the 5 new ones. Problem number 4 says cross ties I and K are parallel. We're looking at these railroad tracks here. Cross ties I and K are parallel. Well, cross tie I is this one right here. Cross tie K is this one right here. Both cross ties are intersected by cross tie H. Here's cross tie H. If the measure of angle 1 is 42 degrees, find the measure of angle 7. All right. So we have these 2 lines here that it says are parallel. They don't necessarily look parallel in the picture because of perspective, but they're railroad tracks. They're never going to get closer together. They're never going to get farther apart. They stay the same distance away. And then they're being crossed by, this one right here. So we're looking at the orange lines and the yellow lines and the 8 angles that are formed by those intersections. We were told that the measure of angle 1 is 42 degrees. So this angle right here is 42 degrees. And we want to find the measure of angle 7. Angle 7 is this one over here. So the first thing I want to know is, are angles 1 and 7 interior angles or exterior angles? Exterior angles. Are they on the same side or the opposite sides of this yellow transversal? Opposite sides. So what kind of angles would we call those? Alternate exterior angles. Angle 1. Can you guys see that green okay? Is that all right? Okay. Angle 1 and angle 7 are alternate exterior angles. And what was the relationship that we learned yesterday? Remember, I jotted them all down over here. What was the relationship that we learned yesterday about alternate exterior angles? They are congruent. So that would mean the measure of angle 1 is equal to the measure of angle 7. Let me write down the congruent statement first, actually. My apologies. Angle 1 is congruent to angle 7, so the measure of angle 1 is equal to the measure of angle 7. I jumped ahead of myself real quick. We know they're congruent. That means their measurements are the same. So how big is angle 7? 42 degrees. Angle 7 is 42 degrees. Beautiful. All right, number 5, something similar. Dennis Avenue is this one right here, and State Street, this one right here, are parallel streets that intersect at Newport Lane along the south side of Oak Creek Park. Newport Lane is the road that is crossing both Dennis Avenue and State Street right here. If the measure of angle 3, here's angle 3, is 62 degrees, measure of angle 3 is 62 degrees, find the measure of angle 4. Let's find angle 4. Here's angle 4. What type of angles are angles 3 and 4? Yep, you're right. They are exterior. They're not in between Dennis and State, so they are exterior. Same side or opposite sides of Newport Lane? Opposite, because this one is above Newport Lane, but this one is below Newport Lane. So this one's north of Newport, this one's south of Newport. So opposite sides of the transversal, exterior angles, what do we call those? Alternate exterior angles, yes. Angle 3 and angle 4 are alternate exterior angles. And what do we know about alternate exterior angles? They're congruent. So the measure of angle 3, jump back, I'm jumping too far ahead again. Angle 3 is congruent to angle 4, so that means the measurement of angle 3 is equal to the measurement of angle 4. So how big is angle 4? 62 degrees. 62 degrees equals the measurement of angle 4. That's okay, 62. We can make this statement here that angle 3 is congruent to angle 4 because of the alternate exterior angles theorem. If I was doing a proof, my reason for why I can say this is my alternate exterior angles theorem. If I know two angles are congruent, why can I say their measurements are equal? Thinking about stuff off your red paper now. If I know two angles are congruent, why can I say their measurements are equal? Yes. Definition of congruent angles. Please make sure your phone stays put away. Definition of congruent angles. What'd you say? Alternate exterior angle theorem. Yes, that's an angle symbol. It's a little messy, but. What did I do to go from this step to this step? What changed? Measurement of angle 3 got replaced with 62. We were told up here that angle 3 was equal to 62 degrees, so why can I make this replacement? Substitution. We are going to do proofs again in this chapter towards the end after we learn about all these special angle relationships and we've had a chance to practice with them. But there will be problems along the way where we stop and we justify each step that we take so that we don't get out of the habit of being able to do proofs here. All right, let's look down at the bottom of the page. Problems 6 and problem 7. Using the following diagram, find the rest of the angle measures. What angle measurement do we have? 120 degrees, this angle right here. If I'm looking only right here, I don't pay attention to this at all. I can find linear pairs and I can find a vertical angle. What would be the vertical angle to 120 degrees? Angle 4. So how big is angle 4? 120. What's the name for the special angle pair here between the 120 and angle 2? What do we call that? Linear pair. And what do we know about linear pair angles? They add up to 180. So 120 plus what would give me 180? 60. So angle 2 is 60 degrees. 120 plus 60 equals 180. What's this special angle name pair between the 120 and angle 3? That's also a linear pair, so those add up to 180. Yep, they share this side right here. So these two angles are a linear pair. So how big is angle 3? Also 60. I have another way that I could have figured that out. Once I knew that angle 2 was a linear pair to this, and I found out that angle 2 was 60, what's the special name for angle 2 and 3? Those are vertical angles, so they're going to be congruent. Absolutely. All right, so far that's all just review stuff. That's stuff that we've talked about before with vertical angles and linear pairs. Once I start looking at this second line over here that is parallel to this one, speaking of, how did I know from looking at the picture that they were parallel? It didn't say it. Yes. These little arrows right here, not the one on the very end, but the one that's like on the line. Yes, sir. Why is angle 4 120? Because these two angles are vertical angles, and vertical angles are congruent. Yeah. These little arrowheads right here mean parallel. All right. Is everybody good so far with how we got the 60, 60, and 120 over here before we go on and add anything new using our new relationships? All right. We have the 120 degree angle right here. And I want to figure out angle 5. Because angle 5 touches a different line than the 120 degree angle, touches a different parallel line, it's not going to be vertical angles or a linear pair. These are the two that I'm looking at for interior or exterior. Are these two highlighted angles interior, exterior, or one of each? One of each. Are they in matching corners? What do we call matching corner angles? Corresponding. What's the relationship of corresponding angles? They are congruent. So how big is angle 5? 120. Fantastic. All right, let's move on to angle 6. Right here. 120 and angle 6. Interior, exterior, or one of each? Exterior. Same side or opposite sides of this transversal? Same side. They're both on the top. They're both above. What do we call same side exterior angles? What do we call same side exterior angles? Consecutive exterior. Yes. Consecutive exterior angles. Both of my consecutives, consecutive exterior and consecutive interior, have the same relationship. What is that relationship? Supplementary. So they add to 180. So how big is angle 6? 60. Angle 7. This is the next one we want to figure out. 120 and angle 7. Interior, exterior, or one of each? One of each. Are they in matching corners? No, this one is in the upper left corner. This one's in the lower left corner when I look at where the lines cross. So they're not in matching corners, which means they're not corresponding. We don't have a name for this particular pair. We don't have a name for when it's one of each, interior and exterior, but they're not matching corners. So we're going to have to use some other method to figure this out. Well, here's angle 7. Didn't we already figure out angle 6? They're vertical angles. And so how big is angle 7? 60. Nicely done. All right, last one up here, angle 8. Interior, exterior, or one of each. Exterior. Same side or opposite sides of the transversal? Opposite sides. So what do we call these? Alternate exterior. And what's the relationship between alternate exterior angles? Congruent. So how big is angle 8? 120. Nicely done. Very nicely done. Number 7. Use the figure to find the value of the indicated variable. Justify your reasoning. Part A says the measure of angle 3 is 4x plus 7. So the measure of angle 3, this angle right here, is 4x plus 7. I'm not going to put the degrees symbol around it because I don't really have room. And then it says the measure of angle 6 is 5x minus 13. Angle 6 is right here. 5x minus 13. Are these two lines parallel? How do we know? Got those little pink arrows on it. So these are parallel, which means L is my transversal. Are angles 3 and 6 interior, exterior, or one of each? Interior. Same side or opposite sides of the transversal? Opposite. One is above line L. This one is below line L. So opposite sides of the transversal, but interior. What do we call those? Alternate interior angles. Angle 3 and angle 6 are alternate interior angles. What's the relationship for alternate interior angles? They're congruent. So angle 3 is congruent to angle 6. If those two angles are congruent, what does it mean about their measurements? Yes, their measurements are equal. The measurement of angle 3 is equal to the measurement of angle 6. What can I put in the place of the measurement of angle 3? 4x plus 7. And what can I put in the place of the measurement of angle 6? 5x minus 13. Let's pause for just a second. I'm not going to write down the reasons, but I want to talk about why we're allowed to say everything that we've said so far. Once we identify that these angles are alternate interior angles, I can say they're congruent because of the alternate interior angles theorem. If I know they're alternate interior, I'm allowed to say they're congruent by the alternate interior angles theorem. Then I can say that their measurements are equal by the definition of congruent angles. And then I can plug in these pieces with x's and numbers using substitution. All right, where do I go from here if I want to solve this? Subtract 4x from both sides. So if I subtract 4x from both sides, I would have 7 equals x minus 13. Then what? Add 13 to both sides. So how big is x? 20. 20 is equal to x. Very nicely done. Before we go on and look at the next problem, what questions do we have? What questions are there? Okay. Let's go look at part B then. Part B, we're going to use angle 3 again, except it has a new measurement. It says angle 3 is 3y minus 2. So right here is going to be 3y minus 2. And then we also have the measurement of angle 8, which is right here. It says that's 68 degrees. Angles 3 and 8. 3 and 8. Interior, exterior, one of each. Got one of each. Are they in matching corners?
Oh, wait, no.
No. This one's on the top, because I've got top, bottom, left, and right. Over here, we're on the right. So I don't have matching corners. Are they corresponding? No. Do I have a name for this one? Nope. If they're one of each, one interior, one exterior, but they're not matching corners, I don't have a name for it. So I'm going to have to find something else. Do you remember up here when we were finding angle 7? We didn't have a name for the 120 degree angle and angle 7, and so we used vertical angles to figure this out. What's a vertical angle for angle 8? Angle 5. Angle 5 would be congruent to angle 8 because they're vertical angles. So this is also 68 degrees. So I'm going to write that down. Angle 5 is congruent to angle 8 because they are vertical angles. So the measurement of angle 5 is equal to the measurement of angle 8, which means angle 5 is 68 degrees. That doesn't answer my question. I was asked to find why, but now that I know how big angle 5 is, do I have a special name for angles 3 and 5? They're interior, same side or opposite sides of the transversal. Same. What do we call same side angles? It starts with a C. Consecutive. My consecutive angles, whether they're consecutive interior or consecutive exterior, what's the relationship? Supplementary. Angle 3 and angle 5 are consecutive interior angles. So the measure of angle 3 plus the measure of angle 5 equals 180. In the place of the measure of angle 3, I'm going to put 3y minus 2. Plus, in the place of the measure of angle 5, I'm going to put 68 degrees. Is equal to 180. Before I finish solving this, we identified 3 and 5 as consecutive interior angles. So the reason I'm allowed to add them and set it equal to 180 is because of the consecutive interior angles theorem. That's why I know they're supplementary. And then I can put 3y minus 2 in the place of angle 3 and 68 in the place of angle 5 using substitution. All right, what do I want to do next to solve this? Yep, we're going to combine these like terms together right here. What is negative 2 plus 68? Yep, 66. So 3y plus 66 equals 180. Then I'm going to subtract 66 from both sides. What is 180 minus 66? How much? 114, thank you. So 3y equals 114. Then we divide both sides by 3. Does this go in evenly? Yes. What do we get? 38. Y equals 38. Nicely done. Flip this over to page 5. Flip this over to page 5. Describe the following vocabulary words. So we're going to rehash this again so that we can find these relationships. Interior angles are angles between two lines cut by a transversal. Angles between two lines cut by a transversal. So exterior angles would be angles that are not between two lines cut by a transversal. Vertical angles are opposite angles formed by intersecting lines. So like these two. And what's the relationship for vertical angles? They are congruent. Vertical angles are congruent. Linear pairs are adjacent angles. Means they share a side. Adjacent angles that together make a straight line. What's the relationship for linear pair angles? Are they also congruent? No. What's the other relationship that we've talked about? If they're not congruent, they are supplementary. Vertical angles are always congruent. Linear pair angles are always supplementary. Corresponding angles, angles in matching corners. When I have two lines cut by a transversal. Alternate interior, alternate exterior angles. These are angles that are on opposite sides of the transversal. opposite sides of the transversal, and each touching a different line intersected by the transversal. And finally, we have consecutive interior and consecutive exterior angles. These are same side of the transversal. And each touching a different line intersected by the transversal. Thank you. You're going to need the bottom 3 papers, orange, yellow, and white.
Okay.
You're welcome. Right. This is not even the page that we're on. You need to put your phone away, take your headphones off, and get on the correct page, please. Yes. We are on page 5 right now. Page 5. All right. Leave this up for about 30 more seconds so you can finish getting it into your notes. If you're going to need more than 30 seconds to finish this up, please snap a picture so that you can continue to copy it into your notes. All right. Let's see how well we can do with identifying these different types of angles. We had some practice yesterday. We've had a little bit of practice today still. Interior angles. In this picture over here with lines L, M, and N, what are my interior angles? Four and 3, and then what were the other 2? 5 and 6. Beautiful. What about the exterior angles? Which angles are exterior? 1 and 2. And which were the other ones? 7 and 8. Sorry, I'm just a little bit behind you guys. All right. What about alternate exterior angles? Alternate exterior angles. Angle 2 and angle 8, and then you said 1 and 7. Angle 1 and angle 7 are my alternate exteriors. What about my alternate interiors? Four and 6, angle 4 and angle 6. What's the other pair of alternate interiors? 3 and 5, angle 3 and angle 5. Corresponding. Now I need matching corners. What are my corresponding angles? I heard 2. 2 and what? 2 and 6. Angle 2 and angle 6. That's going to be my upper left and upper left. What's another pair of corresponding angles? Angle 1 and angle 5. That's my lower left, lower left. What's another pair? Angle, which one? Angle 4 and angle 8. Angle 2 and 7. 3 and 7. Upper right, upper right. Angle 3 and angle 7. I love it. Corresponding angles, because I always have 4 corners when 2 lines cross, I'll always have 4 pairs of corresponding angles. Alternate interior, alternate exterior, and my consecutive interior and exterior, I'll only have 2 pairs. What's one pair of consecutive interior angles? Same side, consecutive interior angles. 1 and 5? 4 and 5, yes. 4 and 5. Angle 4 and angle 5. They're both in between the lines, and they're below the transversal end. What's the other pair of consecutive interiors? 3 and 6. All right, last one, consecutive exterior. 2 and 7, angle 2 and angle 7. What else? 1 and 8, angle 1 and angle 8. That was fantastic. So given that we just learned about these yesterday, and we were a little confused by them still yesterday, how are you feeling about identifying these special angle pairs now? Do you feel like at least here? Give me a real quick. You feel confident to identify? You're like, I'm starting to get it, or you're still completely lost? Give me a real quick, how are you feeling? Nice. All right, down at the very bottom of the page, if the lines are parallel, what are my congruent angles? Oh, sorry, not numbers. I want to know what types. My apologies. That's my bad. What types of angle pairs are congruent if the lines are parallel? Vertical angles are always congruent. Yep. Vertical angles. What else? Which ones of these? Alternate exterior angles are congruent. Alternate exterior. What else? Alternate interior, yep. Alternate interior angles. There's one more. One more. Vertical angles, alternate exterior, alternate interior, and one of these other types of angles here. Corresponding. Corresponding angles. What about supplementary? What types of angles are supplementary when the 2 lines are parallel? Yes. Consecutive interior angles. Consecutive exterior angles. And there's one more. And this one doesn't matter if the lines are parallel or not. Linear pair, yes. Squeeze that in at the end. So my consecutive interior, consecutive exterior, and linear pairs are the ones that are supplementary. All right. that is where we are going to stop for today. And we will pick up with page 6 tomorrow. Your homework is due on Tuesday. Homework is due on Tuesday. So we still have one more day of this lesson where we're going to continue practice, but you absolutely can get started. From here on out, it's just more practice. We're not adding any new information on top. We're just going to keep practicing.